We're going to see why this works in a second. Right now, we just found out that this makes no sense whatsoever, that it's really weird, and that matrix multiplication actually involves multiplication and adding. And they have to be compatible. So in order to be compatible, in order for the matrix multiplication to actually work, you have to have the same number of columns in that first matrix must be equal to the same number of rows in the second matrix. So when we're putting them together, we're really looking at, when we write the orders underneath, do the numbers match up? So here's with any numbers. Let's just say we started with a 3 by 2 matrix, and then we multiplied by a 2 by 5 matrix. See that those two middle numbers, the number of columns in A and the number of rows in B, are the same. These two middle numbers have to be the same in order for you to multiply. Anytime that they're different, it won't work. And A times B is not the same as B times A. So unlike regular multiplication where it doesn't matter the order, in matrices it does matter the order. Yeah. And then here, the size, whatever you're left with on the outside, that's how big your matrix is going to be. So we looked at an example which was a 3 by 2 matrix multiplied by a 2 by 3 matrix. And let's call this one C. No, we're using C already. Let's call this one D and E. So if we multiplied those together, the middle numbers are the same, so we know we're allowed to multiply them. And the answer that we would get, say matrix F, would be a 3 by 3. But if you multiplied E times D, it's still possible to do because our middle numbers are still the same. But now we're going to get a new answer that's different because it's going to be a 2 by 2 matrix. Not going to be the same. And if you tried to do something like E squared, it would be not possible because this is a 2 by 3 multiplied by another 2 by 3, and these middle numbers are not the same, so it wouldn't be possible. So our middle dimensions must be equal. Here we have a 3 by 2, and here we have a 2 by 1. Our middle numbers are the same, so this means that you can multiply them. And the answer you would get would be a 3 by 1 matrix. Yes? No. Then there would be nothing there. Then it wouldn't be a matrix. You can only square squares. Yep, the only matrices that can be multiplied by themselves are square matrix. Okay? Here we have a 2 by 2, and this one is a 1 by 3. Our middle numbers are not the same, so we can't multiply these together. No. If we can multiply them together, we've already seen that the resulting matrix, so this one was a 3 by 2, and this one was a 2 by 1. The resulting matrix that we get is, after we notice the middle numbers are the same, whatever is left on the outside is how big our answer is going to be. So we know that when we're multiplying these together, there's going to be 3 spaces that we're going to have to figure out. And to figure out the answer, what we need to do is multiply each row by each column and then add it up. Okay, so we're going to get the 23. I'm going to color code this here so that you can see it easy. In our answer, the 23 is in row 1, column 1. That's its position. Row 1, column 1. And so in order to get that value, you need to take the numbers in row 1 and multiply by the numbers excuse me, in column 1. And like I said before, I imagine that first row turning it on its side like a transpose. So that 1, 2, turn it. Once it's turned, slam it through and multiply. 1 times 7 is 7. 2 times 8 is 16. And add those up. That's the visual that I always give myself every time I multiply matrices. So sometimes I add sound effects while I'm doing it myself. People, what are you doing? Oh, I'm just multiplying matrices. Makes it more fun. So our second one in the answer, well, this 53 is still in column 1, but now in row 2. So I would have to take row 2 and multiply it by column 1. So I imagine that row 2 turning. The 3 hits the 7, the 4 hits the 8. And we get 21 plus 32, which is 53. And finally, row 3, column 1. If I took my third row and multiplied it by my first column, the 5 would hit the 7, the 6 would hit the 8, and 35 plus 48 is 83. And that's how matrix multiplication works. Now, it can get very big or very small depending on the matrices that you're working with. All right, so here are some to try, some to work on, and I'll put up the answers in a bit. Right, ready to see that again? Got the answer for A and B? Was better the first time? Can't rewind time. Shoot. Have you got B times C already too? No. Some yes, some no. Okay, wait a bit.